So welcome students. So in the last class we discussed about basic measurement units and how we are going to, what are the physical quantities, what are the derived quantities. Now we are going to discuss about the basic quantities and what are their units. Okay, so the first basic quantity is length. Length means we will measure it in meters and centimeters, or meters, centimeters, mm, and sometimes kilometers also we can measure. Okay, if you come to when we consider length, the basic what we take it as 1 meter. Okay, and this 1 meter, after 1 meter we will be having decameters. Okay, like how it will be, I will show you. Let's see. First mm will be there. Okay, 1 mm will be there. Okay, so next after 1 mm, if you multiply this 1 mm, 10 mm's will become 1 centimeter. Okay, and 10 centimeters will become 1 decimeter. Decimeter will be smaller. Okay, and 10 decimeters will become 1 meter. Okay, so from mm to 1 meter, how many numerical numbers are there? 10 and 10 and 10. So that's the reason why 1 meter is equals to 1000 mm. Okay, so after after meter, you will be having 10 decimeters is equals to 10 meters is equals to 1 decimeter, capital. Okay, so 10 decimeters is equals to 1 hectometer. 10 hectometers is equals to 1 kilometer. So this is the lengthwise conversions. Okay, so 1 kilometer is equals to, so from 1 kilometer to 1 meter, how many tens are there? 3 tens are there. 10 into 10 into 10. That's the reason why we will be having 1000 meters for 1 kilometer. So these kind of calculations you need to remember. Okay, so actually we are having 3 types of systems. One is MKS, CGS and SI. SI, standard of international units, now we are using. CGS means centimeter, gram and second. MKS means meters, kgs and seconds. Okay, so now we are not using MKS and CGS. Of course FPS is also there, foot, pound and second. Okay, now we are not using all these things. Now we are using only standard of international systems. According to the standard of international systems, length is meters, the units are meters. For mass it is kgs. For volume, meter cube. For temperature, degree Kelvin, not degree centigrade, we are using only degree Kelvin. And for time we are using seconds. So let's see what are the instruments we are going to use to measure all these things. Okay, so if I want to measure length, what are the instruments I can use? I can use steel rule. Okay, I can use VC. VC means vernier calipers. Okay, if I want to measure any sphere, any spheroidal diameter, I need to use micrometer. Okay, so all these things are needed in your general physics. Okay, so to measure length we are going to use vernier calipers, steel rule or micrometer. Okay, all these kind of things. To measure mass, okay, that's a different kind of thing. To measure mass you need to use some simple bands or something else. It's not in our syllabus, we don't need to check that one. To measure time you need analog or digital stopwatches. Okay, and to measure temperature you need thermometers. Okay, so these are all needed things. Okay, so when coming to why we are discussing about all these things means these are the main basic criteria we should know about. Okay, physical quantities means physical quantities are the combination of, I already told you, a physical quantity PQ is always the combination of its numerical number and its unit. If you want to get unit, you need you need to get with respect to the any numerical value. If you want a numerical value, you need some instrument to measure that physical quantity. So without any instrument, we may not be able to measure any kind of physical quantity, and we may not be able to get any kind of numerical number. Okay, so that's the reason why we need our instruments are very, very important. Okay, and apart from instruments, there are certain things which are very important, that is errors. Okay, errors are usually three types. Okay, the first one is zero error. That means the instrument, we are not able to measure the instrument from zero. Let's say, for example, a steel rule is there. This is 0 and this is 1 centimeter, 2 centimeters, 3 centimeters. In between this we are having mm's. Okay, so here in this steel rule, what happened is, because of some reasons it has broken at this part. Okay, so if it broken at this part means we may not be able to use, and we cannot take 0. Then what we will do, we will start measuring from 1. Okay, if we measure any kind of length from 1 to 3 means, what would be the total length from 1 to 2, 1 to 3? It will be 2 centimeters. Like that we have to take that zero error. Zero error means in the instrument only we are not able to fix the 0. That is what we call it as zero error. Okay, next, parallax error. Okay, parallax error means, suppose there is a dial. Okay, and these are the readings. Okay, and this is the indicator. Okay, if you are watching from right, so parallax error means it's completely because of our perception. If you are watching from this, right side, the dial may be, you can see the dial will be in the left one. If you are watching from left, the dial will be from right. If you want, otherwise you do one thing, just take a finger. This is my finger. Okay, if you are watching it from, by closing your right eye, if you are watching it from left eye, it will be slightly rightish. In case if you close your left eye and open your right eye, it will be somehow some leftwards. It will be. Okay, so this is what parallax error. How can we how can we avoid or prevent this one? You should never watch it from left or right. You should watch it from perpendicularly. Okay, then only, if a pen is there, you should not watch it from right side or left side. You should watch it from top. Okay, that means perpendicular to that one. Then only this parallax error may be relieved. Next, meniscus. Meniscus means there is a beaker, suppose. Okay, a round beaker is there and it contains water. Okay, what we usually see, the beaker is rounded. Actually the beaker is round shaped. Okay, and the indications are like this. This is the water level, what we consider, what we assume, what we see actually. Okay, this is the water level. Okay, but actually the water level is like this, but actually the beaker is rounded, right? So the beaker will be like this. Okay, there will be a slight change like this. Okay, because of this there might be a change of dimensions, maybe one slightly 0.5 to 0.25 mm. Okay, this is also called it as meniscus error. Okay, so these are the main errors we need to focus and we need to study. Okay, so please be cautious about these topics. The next thing we are going to deal with is density. Density, it is the ratio of mass and unit volume. Okay, so it is indicated by rho. Okay, sometimes we will write it like this. So density is equals to mass by volume. The units for mass is kg, units for volume is meter cube. So units for density is kg per meter cube. Very important. You need to be cautious and focused on this particular one. Okay, and next, specific volume. Okay, so you should write it like this. I mean, I am writing in shortcut way. You should never write it. Specific volume, indicated with small v. It is the inverse or reciprocal of density. That means specific volume is equal to 1 by rho. 1 by rho means mass by volume will become volume by mass. Okay, so this we call it as, I mean, the units will be meter cube per kg. Got it right? So density means mass per volume, kg per meter cube. Specific volume means reciprocal of density. It is volume per mass, meter cube per kg. Okay,